I want to look at some more examples where we find the composition of functions. So here's problem 4. In the last couple of videos, we did 3 problems already. So this is the 4th problem. And this problem says, for each of the following functions f and g below, I want to find f composed of g, g composed of f composed of f, and g composed of g. And then for each of these compositions, I want to state the domain. And then afterwards, I want to find parts A through E. So let me just show you what we're going to do. So this is the first example. So we have f of x is 3 minus 5x, and g of x is x plus 1. So let's find the domain and the range of both of these. Then find, sorry, not the range. You can find the range for this, but really we just want to focus on the domain. That's what the problem asks us to do. And then we want to find the domain of all of these compositions. And we also want to come up with an equation for each one of these compositions. And then here's parts A through E. And this is just where we're evaluating the function at particular values. So I'm going to start with the domain. I'm going to put some space here. So I'm going to just say D for domain. So the domain of F, and let's talk about the domain of G. So looking at this function f, this is the equation of a line. The line has a slope of -5 and a y-intercept of 3 here. So the domain of the line is all real numbers. This function here is also a line. The slope is 1 and the y-intercept is 1. So the domain is all real numbers. Up to this point, if you see a function that has no square roots and no fractions, then the domain is going to be all real numbers. Later on, we're going to talk about exponential functions and log functions. And when we talk about that, we're going to have to talk about other domains, things we have to take out of the domain. But up to this point, we've only seen square roots, fractions, and like lines like this are polynomials. So if I don't see a square root and I don't see a fraction, we're going to say the domain is all real numbers. And remember what the domain is. The domain is all the values you can plug into x. And if we don't have square roots and we don't have fractions, then there's nothing that we can't plug in for x. That's why the domain is all real numbers. When we deal with square roots, we have to only plug in positive values or 0, because then we're going to get square roots of negative numbers, which don't exist under the real line. And then with fractions, we have to worry about dividing by 0. Okay, so the domain of f and the domain of g are both all real numbers. Now let's find f composed of g. So I'm going to put this, I guess, in white. I want to find the equation for f composed of g of x. And then we're also going to find the equation for g composed of f of x. And then f composed of f of x. And g composed of g of x. Once we find the equations, then we'll talk about their domains. Now let's recall what f composed of g of x is. This is f with g plugged in. Now before, we were just plugging in a single value. Here we're going to plug in the whole equation. Okay, so what I'm going to do is I'm going to keep f, and instead of this g of x, what I'm going to write, I'm going to actually put x plus 1 here, because that's what g of x is equal to. So what I'm going to do is I'm going to take this function f, and wherever I see an x, I'm going to plug in x plus 1. So f of x plus 1 is 3 minus 5 times x plus 1. And I can simplify this. This is 3 minus 5x minus 5 by distributing this -5. And then simplify it a little bit more because we have this 3 and this -5. So that is -5x minus 2. Let me put some more space here. So what we found was f composed of g of x is equal to -5x minus 2. So again, what are we doing? We're taking the function g and we're plugging it into the function f, which is exactly what I did here, and then we simplified it a little bit. So that will be the function f composed of g. So in your homework, if I ask you for the function f composed of g of x, you would write this, negative 5x minus 2. Now let's state the domain. Let's put this in red. Okay, we have to remember the rules when it comes to the domain of f composed of g. Let's scroll back up to the definition real quick. Now, a while ago, we looked at this definition about the composition of functions. Here I have g composed of f, but since I'm working with f composed of g, I'm just going to switch all of the letters. So g will become f and f will become g. So like this will be f composed of g, f, and here's g. So the domain of f composed of g is the set of all x in the domain of g, such that g of x is in the domain of f. So what we're going to do is we're going to find the domain of f and the domain of g. And we're going to look and see what we have to take out. So with this example here, what you focus on, you're going to look at this piece before you simplify anything. So you start with the domain of g and you ask yourself, what is it? The domain of g is negative infinity to positive infinity. We don't have to take anything out, okay? Since we don't have to take anything out, then we look at this piece here. And before simplifying, we ask ourselves, is there anything I can't plug in into this equation? Now the answer is no, you can plug whatever you want to into this equation. But when you see fractions or square roots, like we're gonna see later, then you're gonna have to take things out. So the domain is going to be the intersection of this domain, the domain of g, the one that we're plugging inside the function, f. So the innermost function here, you see this one right here, you ask yourself, what's the domain of this? You find its domain, and then you look at this part where we plugged it into f before we simplified, and then we ask ourselves, what's the domain of that? And then we take the intersection. So the domain of this is also negative infinity to infinity. So the intersection of these two is negative infinity to infinity. That's where they overlap. So negative infinity to infinity overlaps with negative infinity to infinity, the whole thing. So it's just all real numbers. Well, this will make more sense when we start seeing things that involve square roots and fractions. But as long as we don't have that, you can go ahead and say the domain is all real numbers. Okay, let's try g composed of f. So I'm going to erase this. And now we want to find g composed of f of x. So let's come up with an equation first and then state the domain. So this is equal to g with f of x plugged in. So I'm going to take g, and inside of it, I'm going to put 3 minus 5x. So this is g. So wherever I see an x, I'm going to put in 3 minus 5x. So this is 3 minus 5x plus 1, because this is where the x was. So if I simplify this, I get 3 minus 5x plus 1, get rid of these parentheses, and that becomes negative 5x plus 4. So this is the equation for g composed of f of x. Now for the domain, what we're going to do is we're going to look for the domain of the inward function, this one on the inside. The domain is all real numbers. And then we look at this step right before we simplified, and we ask ourselves, what's the domain of this? And the answer is all real numbers. And so since the domain of both is all real numbers, then this guy's domain is all real numbers. Okay, let's do f composed of f next. So I'm going to erase all of this. And now I'm going to put an F here and an F here. Just erase that. And an F here. Okay, so I'm going to take F, and inside F, I'm going to put F. So this is taking F and plugging inside it 3 minus 5x. So wherever I see an x in the function f, which this is the function, I'm going to put, instead of x, I'm putting 3 minus 5x. So here's an x, I'm going to put 3 minus 5x. So this is equal to 3 minus 5. So I'm taking the function f, maybe this will help, taking this function, and wherever I see an x, now I'm putting in 3 minus 5x. So I'm putting it inside itself. Okay, now we can simplify this. This is 3 minus 15 plus 25x, because this negative 5 distributes and it changes a sign to a positive. And you're left with negative 12 plus 25x. So that is the function f composed of f of x. Now, as for the domain of this function, this is going to be all real numbers, because the domain of f is all real numbers and the domain of this piece here is all real numbers. So we're going to say that this is negative infinity to negative infinity, to positive infinity, excuse me. All right, so the next piece is to figure out what g composed of g of x is. So let's erase all of this. And I'm going to go ahead and tell you that the domain is going to be all real numbers. Let's see if we can simplify this. So now we focus on this function here. G composed of g of x is g with g plugged in, which is g with x plus 1 plugged in, because that's what g is. G is equal to this. So I'm going to take g, and wherever I see an x, I'm going to plug in x plus 1. So g is x plus 1, and I said wherever I see an x, I'm going to plug in x plus 1. So this is going to be x plus 2. And again, because the domain of the inward function g is negative infinity to infinity, and then this function here is negative infinity to infinity, then the domain of g composed of g is also negative infinity to infinity. All right. The next thing we're going to do is parts A through E. So let me bring that back up. Get rid of that. Okay. So what I want to do is I want to figure out each one of these pieces, and I can do it a couple of ways. Remember that we had equations for f composed of g. So we can now use those equations to figure out each one of these pieces. All right, so let's start with part A. Let's make some room down here and just ignore that part C for now. Put a line here. So we found that f composed of g of x, remember that that was negative 2 minus 5x from that equation we found. So what we can do is we can plug in 0 into this function. And if we plug in 0, we get negative 2 minus 5 times 0, which is just negative 2. So that is the answer to this one. Another option you can use for this is you can actually just use what we did last time in the last video, which we could say f composed of g of x is equal to f with g plugged in, which is f. Now you plug in 0, since we're plugging in 0 here. We plug in 0 into g. So going back to the function g, which is right here, if we plug in 0 into it, we get 1, because 0 plus 1 is 1. So then this is f of 1. And then you go to the function f, which is right here. And if you plug in 1, you get 3 minus 5, which is negative 2. So you get negative 2, which is exactly what we got here. So you can go through all of those steps, which is just 2 steps, right? To plug in 0 to g and then plug into f, or you can use the equation we found. You're going to get the same answer. Okay, get rid of that. Let's go to part B, since that was the second piece that I wanted to look at. So ignore D for now. Let's find f composed of g of 1. Again, we can use the function f composed of g of x, which we said was negative 2 minus 5x. Plug in 1 wherever we see an x in this equation, we'll get negative 2 minus 5 times 1, which is negative 2 minus 5, which is negative 7. Or what we could do is f composed of g of 1. We could say this is f of g of 1. So we look back at our function and plug in 1. So our function is right here. Let me erase this. Just it's so cluttered right now. Let me get rid of this too. Bring this up. So if we plug in 1 into here, so g of 1 is 1 plus 1, which is 2. So then that's the same thing as plugging in 2 into f. So we go back to the function f. And if we plug in 2 into this function, we get 3 minus 5 times 2, which is 3 minus 10, which is negative 7, which is exactly what we got here. So this is equal to negative 7. So it's really up to you. And also it might be a good idea to do both ways just to double check, especially if you have something complicated. If you're sure of your algebra, like you didn't make any algebra mistakes, then you don't need to double check. But if you have like fractions and square roots, you might want to double check. Okay, let's go to this piece, part C. Let's find g composed of f of 1. So I'm going to write again what the equation for g composed of f was. We found that this was 4 minus 5x, I believe. And if we plug in 1 into here, this is 4 minus 5 times 1, which is negative 1. So that's the answer to this. And again, we can double check this by plugging 1 into f, then whatever we get, we plug that into g. So if I plug in 1 into here, f of 1 is 3 minus 5, which is negative 2, and then plug in negative 2 into here, we get negative 1. Okay, let's go with part D. So f composed of f, we said that that was the function. I think we said it was negative 12 plus 25x. Just double check that. And if we plug in 1 into here, this is negative 12 plus 25 times 1, which is, it looks like 13. So again, you can go back up to here. And plug in 1 into f. So if you plug in 1 into f, you get 3 minus 5, which is negative 2. And then plug that value into f again, and you get 3 minus 5 times negative 2, that's 10. So you get 13, which is what we got. And then for the last one, g composed of g of 1, I'm not going to double check this one. We said g composed of g of x is equal to, let me scroll back up here to see. Oh, I deleted it. That's okay. It was x plus 1. I think it was just x plus 2. And if we plug in 1 into here, we'll get 3, which you can double check since I erased it. If you plug in 1, you get 2, and then you plug in 2, you get 3. Okay, let's move on to the next problem. So here I'm giving you the functions f and g. Again, I want to find the domain of f and g. Then I want to find the domain of all the compositions. Let's find equations for the compositions, and then let's evaluate these guys. So let's start with the domain. So the domain of both of these, again, I don't see any square roots. I don't see any fractions. The domain is all real numbers. Now let's find equations for f composed of g of x. Start with that one. So this is f with g plugged in. So I'm going to plug in 3x plus 7 wherever I see an x. So this is going to be, well, f of x is x squared. So I'm going to plug in 3x plus 7. Now you can simplify this, you can square it out. I'm not going to. This is all I really need to do to find this function. So this is the function here. Now if your homework asks you to FOIL it or I guess simplify it, you would want to expand this. But I'm going to leave it just like that. Now let's find g composed of f of x. So g composed of f is g with f of x plugged in. So that's g, well, f of x is x squared. And then we're going to take g, which is 3x plus 7, and wherever I see an x, I plug in x squared, because that's what the definition of this means. So this is 3 times x squared plus 7. So that is the equation for this function. Notice that these are not the same. Now let's do f composed of f and g composed of g. So let's start with f composed of f of x. So this is f with f of x plugged in. So I'm going to look at f. F is x squared. So I'm going to take f and I'm going to plug x squared in it, but x squared is the function. So we're taking x squared and we're squaring that. So we get x to the 4th. That's the equation for this function. And then look at g composed of g of x. Well, g is the function 3x plus 7. So we're taking g and plugging in 3x plus 7. Well, then that's 3x plus 7. But instead of x, I'm plugging in 3x plus 7. And I'm going to simplify this one. This one is 9x plus 21 plus 7, which is 9x plus 28. Now again, like the other examples, the domain of f composed of g, g composed of f, f of f, f composed of f, and g of composed of g is all real numbers, because the domain of f and g are all real numbers. And then these pieces, I don't have any square roots, I don't have any fractions, so it's all real numbers. So maybe I'll write that down here. The domain of all the compositions is all real numbers. So I'm going to do it like that, but you can put negative infinity to infinity for interval notation. Okay, let's figure out A through E here. I'm going to find f composed of g of -1. Let's copy down what this equation was. F composed of g of x, that is equal to, let's go back up here. We said it was 3x plus 7 squared. So all we have to do is plug in -1 into this equation. and that is negative 3 plus 7. That's 4 squared, which is 16. Let's do C next because it's on the right side of this. So G composed of F of negative 1 is, now I'm not going to write the equation again. This time I'm just going to go straight to it. It's 3x squared plus 7. So all I have to do is wherever I see an x, I plug in negative 1. It was 3x squared plus 7. Plug in this negative 1. So this becomes 3 plus 7, which is 10. Okay, the next one is f composed of g of 0. So this is going to be equal to, well, I look at this equation, remember f composed of g, we wrote it here. So I just plug 0 in and I get 7 squared, which is 49. What about d? Let's look back and see what the equation for f composed of f is. It's x to the 4th. So let me write it here. So if I plug in 3 here, we get 3 to the 4th, which is 81. The last one is g composed of g of 3. Sorry for all the scrolling. I didn't write these down. Next time I'll write them down on paper so I don't have to scroll. This is 9x plus 28. So this is 9x, this is the 3, plus 28. 9 times 3 is 27. And then you just add these. I believe this is 55. Just check my math there. That's all you have to do. Okay, now we're getting into some more complicated examples. We're going to do the same things. We're going to find all the domains of the compositions in these functions and then find these guys here. But let's do these first. I want to switch this up a little bit. Now we can do them with the equation like we did before, but this time let's just do it without even finding the equation for f composed of g, just to get more practice with that. So I'm going to do this one first. So this is f of g of negative 1. This is f g of negative 1. So if we plug in negative 1 into g, we get 5 minus negative 1, which is 6. So this is f of 6, which is the square root of 6. I'm just plugging that 6 in here. Let's do c next. So f composed of f of 3. So this is f of 3, which is f. If you plug in 3 here, you get the square root of 3. And then we're going to take the square root of the square root of 3. And that looks a little complicated, but what you can write this is the square root of 3 to the 1/2. And the square root of 3 is the same thing as 3 to the 1/2. So this is 3 to the 1/4. Or you could write it as the 4th root of 3. Okay. Let's do B and D. F composed of g of negative 1. So that's f with g of negative 1 plugged in. So I'm going to move up and I'm going to plug in negative 1 into g, and then I'm going to plug that value into f. So g of negative 1. Did we do this problem? Oh, we already did this one. Sorry about that. I think what I meant to do was switch these two. This should be g composed of f. So let's switch them. Okay. So what I'm going to do instead is I'm going to plug negative 1 into here. And then after I do that, I'm going to plug that value into here. So what's going to happen? F of negative 1 is equal to the square root of negative 1, which doesn't have a value in the real numbers. So we're going to get undefined. So this doesn't exist. And since this doesn't exist, if this part doesn't exist, g of that doesn't exist. And that means this negative 1 is not in the domain of f, and it's not in the domain of g composed of f. Now, it is in the domain of g, Now g, you could plug -1 into here. We did that before. Remember, we plugged in -1. That was fine, but it's not in the domain of f. So when we switch this, when we put g composed of f of -1, we can't do that. And that's why it's important to find the domain of the compositions, because you just can't plug anything you want into them. Let's try this one, g composed of g of 3. Remember, g is 5 minus x. I'm going to write that here. So g composed of g of x is g of, well, if I put in 3 here, I get 2. And then if I put 2 into here, I get 3. So just double check, 5 minus 3 is 2. And then we do g of 2, which gives us 3. So we get the same thing, which is interesting. Okay, now let's go back up here and let's talk about equations for each one of these functions and stating the domain and the range. So move all that down, erase this. Okay, let's start with the domain of f and the domain of g. G is easy, G is a line, the domain is all real numbers. F, remember you can't take square roots of anything less than 0, so it's 0 to infinity. Now let's talk about f composed of g of x. All right, so what we're going to do is we're going to take g and plug it into f, which is 5 minus x. So I'm going to, wherever I see an x, I'm going to plug that in to this function, which is the square root of 5 minus x. Now let's talk about the domain. I'm just saying d of f composed of g. So we start with g, the one in the innermost function here, g, and we ask ourselves, what is the domain? The domain is all real numbers, so we're okay. And then we ask ourselves, when we got to this point here, f composed of g, what is the domain of this function? Well, this is a square root. And the rule with the square root is anything underneath that square root has to be greater than or equal to 0. So if we move the x to the other side, we get that x has to be less than or equal to 5. So now we take the intersection of these two domains, the domain of g, which is -infinity to infinity, and also the domain of this piece here, which is anything less than 5. And that intersection, so maybe we can draw it on a line, a number line. -infinity to infinity is all of this, so maybe we'll do it in blue. And then if we put the number 5 here, and we do the other one in green, -infinity to 5, including 5, where they overlap is -infinity to 5. So this domain is -infinity to 5. Okay, let's try the domain of g composed of f and the function g composed of f. Okay. So what is g composed of f of x? This is g with f of x plugged in, which is g with the square root of x plugged in, which is, okay, here's g. Wherever I see an x, I plug in the square root of x. So this is 5 minus the square root of x. Okay, now that we're here, we can look and see what the domain of the inner function is, which is f. The domain of f is 0 to infinity. And then we look at this function and we see what the domain of this function is. And the problem we have is anything under the square root has to be greater than or equal to 0. So the domain of this function is 0 to infinity. And the intersection of these two is 0 to infinity. So that's the domain of the composition. Great. Now let's move on to the next one, which was, let's go with F composed of F, and then G composed of G. Maybe we can do these at the same time, since we're becoming good at them. So F composed of F is taking F and plugging it in itself. So this is F of the square root of X, which is the square root of the square root of X, which remember we saw before, this became to 1/4. So this is X to the 1/4. And G composed of G is taking G and plugging 5 minus X inside it, which is 5 minus X, that's the original function, this one on the outside, and we plug 5 minus X inside. So we get 5 minus 5, which is 0, and then we get X. Okay, and so we found these two functions. Now let's talk about their domains. G composed of G is actually easy to figure out because the domain of G, the inward function, is negative infinity to infinity, and the outside function, which is this guy here, is also negative infinity to infinity. So its domain is negative infinity to infinity. Then we talk about F composed of F. The domain of the inward function is 0 to infinity. And that's the domain of this one as well, because you can't put anything that's negative in here. So the domain, I'm just going to write like this, the domain of this is 0 to infinity. And now with these equations, you can use these if you want to and double check these values that we got before. Like this G composed of G of X, we got just X. And you could see that when we plugged in 3, we got 3. If you plug in something else like 1, you'll get 4, and then you plug in 4, you get 1. So you just get the same thing back. And that would make sense with this one too, because we got X to the 1/4, and we plugged in the 3, and we got 3 to the 1/4. Okay, let's do another problem. Here I have both square roots and fractions. I have F is 1 over X, and G is the square root of X plus 1. Right, let's come up with formulas. Let's do that first. I'm gonna make a lot of space because I always don't put enough space. Let's find the domains of F and the domain of G. The domain of F is all real numbers except 0 because you can't divide by 0. And the domain of this one, this X plus 1 has to be greater than or equal to 0. So X has to be greater than or equal to -1. Now let's figure out F composed of G of X. Let's find a formula. So we're going to take F and plug in G of X, which is F with the square root of X plus 1 inside of it. So wherever we see an X, we put square root of X plus 1. So this is 1 over the square root of X plus 1.